Next problem. In a capacitor circuit, a charge of 120 microcoulombs is flowing with a current of 0.4 milliamps. Find the total time it takes for all these charges to pass. This is a similar problem to the last time. The only problem, or the only issue here, is that we're given in units that aren't originally coulombs or amperes. So let's take a look at our given. For our charges, we've got 120 microcoulombs. For current, 0.4 milliamperes. And it's asked us to find time. So time is still undefined. Before we start using the formula, we have to convert the microcoulombs into coulombs. So, in 1 microcoulomb, how many coulombs are there? So we all know that 1 microcoulomb is just 1 times 10 to the power of negative 6 coulombs. So put that in your calculator and you should end up with 120 times 10 to the power of negative 6 coulombs. You can also further simplify this into 1.2 times 10 to the power of negative 4 coulombs. And the reason for that is because our decimal point starts here and we want to make the decimal point right beside the 1, right? So we have to move 1, 2. And since we move 2 decimal places to the left, we got to increase the raised to the power by 2. So negative 6 plus 2 is negative 4. And our decimal place is right beside 1. So now it's 1.2 times 10 to the power of negative 4. Same thing for the milliamperes. We got to convert milliamperes into normal amperes. So in 1 milliampere, there are 1 times 10 to the power of negative 3 amperes. Put that on your calculator and you'll end up with 0.4 times 10 to the power of negative 4 amperes. However, in this case, we want to simplify it even more. So we have to move the decimal place to the right of 4. So we move the decimal place to the right by 1. So we gotta decrease the power by 1 because we move the decimal place by 1. So negative 3 minus 1 is negative 4. And the decimal place is at the right, so it's 4 times 10 to the power of negative 4 amperes. You could simplify it like I did, or you could just run through it, but the answer will still be the same. So that's just up to your personal preference. Now that we have all the variables and the coulombs, we can now put it into the formula. So we've got 1.2 times 10 to the power of negative 4 coulombs divided by our amperes of 4 times 10 to the power of negative 4. And we'll end up with a value of 0.3 seconds. So it only took 0.3 seconds for the 120 microcoulombs to pass from the current.